Hi everyone. Now I am going to discuss about the how to find moment of inertia of rigid body without integration. For that, I have taken three bodies. One is a thin rod, finding moment of inertia about its center of mass. Second one I have taken from the pathfinder, that is like a triangular lamina. For triangular lamina, how to find out the moment of inertia about its centroid and perpendicular to its plane. And third one is a square plate having mass m side A about its center of mass. These three questions I am going to do by using the integration without integration. Okay. Also, I have taken the two previous year JEE mains questions like this. Actually, ABC from ABC triangle, center part is removed. Center part of the triangular part is removed, and one more thing is ABC triangle is there. In that ADE part, upper part of the triangle is removed. Okay, how to calculate the moment of inertias? You can see now. Okay. Thin rod of mass m length L, I am going to calculate moment of inertia about it, center of mass of the rod. Before going to discuss about the moment of inertia about the center of mass of the any rod, I am just recapping what is a moment of inertia. Let us consider there is an axis and there is a particle of mass m which is at a distance r, a perpendicular distance r from the axis. As you know that moment of inertia of this particle about the axis is m into r square. We can see here the moment of inertia of this particle is depending on the mass of the particle and square of the distance. Square of the distance is nothing but how this mass is distributed around the axis. Okay, moment of inertia depends upon the mass as well as mass distribution. Okay, here square of the distance. Same logic you apply for the rigid body also. For rigid body like rod, I don't know what is the moment of inertia of any rod. Suppose if I take this is the rod having mass m, rod is having mass m, length L, the moment of inertia about its center of mass is I don't know. That's why I'm taking this as I is equal to k into m into L square. K into m L square. Now I am going to calculate how to calculate this one is by using just one method I am giving, that is scaling method. Okay. For that to calculate this k into ml square value, k value or moment of inertia about the center of mass, I am actually taking three steps. Step 1, instead of taking the single rod having mass m and length L, I am taking the a composite rod. This is what a composite rod having mass is 2m, length is 2l. Okay, according to our relation you can see here the center point is same here, mass m, length l here, and here also mass m and length l. We can treat this as there are the two rods having mass is how much, m dash is equal to 2m, length is equal to 2l. This moment of inertia of the composite rod can be written as k times the 2m into 2l whole square. You can write this is 2 into 4 is you can write it as 8k into m into l square. So I can write this as 8i. I can write this as 8i. If I write this moment of inertia in other manner, step 2, I can treat this rod as two small rods having mass ml about one end. That's why I'm writing in the step 2. I can write this as two rods having mass m, length l. Okay, about end point. Okay, so this I am writing as 2 times the I dash. What is my I dash? I dash is moment of inertia about end of the rod. end of the rod having mass m, length L. Okay, if you observe this, both 2 I dash value and this 8 I value both are equal. I have equated this. Why? Because a single composite rod about center can be treated as two rods at one end. Okay, I dash value we can write as 4I. I have calculated moment of inertia about the one end of the rod is equal to 4I. Okay, two steps I have taken. Third step, step 3, I am going to use the parallel axis theorem. Parallel axis theorem. What is a parallel axis theorem? If you take any rigid body having mass m, if axis passing through the center of mass of this rigid body is, let us consider this is the axis ICM. If I draw any line which is parallel to the center of mass axis, which are separated by a perpendicular distance d, as per the parallel axis theorem, you can write the moment of inertia about axis is equal to moment of inertia about the center of mass plus mass of the body into square of the distance between them. This is our parallel axis theorem. Now, in step 3, I am going to use the same parallel axis theorem. We can observe here. This is my single rod having mass m, length L. This is my axis, end of the rod, that is axis, and center of mass axis is passing through this. According to my thing, I have taken this moment of inertia about this point is I dash, moment of inertia about this is center of mass is I have written. Okay, I dash is equal to about center of mass is I plus mass into square of the distance between the two axes is L by 2. I am writing L by 2 whole square. So 4I is equal to, as earlier I have written, this I dash value calculated, that is 4I. Okay, I am writing 4I is equal to I plus m L square divided by the 4. We can write 3I is equal to m L square divided by the 4. So finally you will get the I is equal to m L square divided by the 12. This is our required answer. Okay, moment of inertia about the center of the any rod. Okay, if you take any rod having mass m, length L, moment of inertia about its center of mass of the rod is I is equal to ml square by 12. Okay, I have taken k. I don't know actually earlier what is the k value. Okay, that k value I calculated. Why I have taken k value? You know that mass is directly moment of inertia proportional to m and distribution. This distribution value is here dimension of the rod L square. I don't know how it is depending. That's why I have taken some constant k. That k value I calculated. I is equal to ml square by 12. Okay, now you see the second question. This is a pathfinder question. This pathfinder question, you can see there is a triangular lamina of side L and mass m. What is the moment of inertia about the axis through the centroid and perpendicular to its plane? Same thing I am taking here the moment of inertia about this center point. Let us consider the G. Moment of inertia about this I is equal to, I don't know what is a k, so just I am taking one unknown term is how multiplier is there k, and m into its mass is m, dimensions are what here L. So we can say that I is equal to k ml square. Our step 1. Now this time I am taking a triangle. This is triangle. This triangle having mass 4m, side is 2L. I am taking this at side 2L, side 2L, side 2L. Why I am taking mass 2m? Reason is I am going to divide this big triangle into 4 small triangles. Okay, each one is having mass m comma L. This is also mass m side L. This is also mass m side L. This is also mass m side L. This is our G value. Okay, everywhere there is a centroid points will be there. Now you can see here there are the 4 centroid points. I am now taking like a new mass of the our 4 m and 2L side is 4m. New side is equal to 2L, and new moment of inertia can be written as k times the 4m into 2L whole square, that is 16 into kml square. Already we have taken the kml square is I. We can write this as 16 into I is a moment of inertia of the this 4m mass having side 2l about centroid G. Okay. Step 2, what I am going to do is just you can see that this can be written as about G. I am calculating here. There is a single triangle about G plus 3 triangles. You can take that 3 triangles like this. Triangle having mass m, length l, here mass m, side length is l, and this is my G. Now you know that this distance is equal to vertex to the centroid distance is L divided by the root 3. This distance also will be how much here? Centroid to the any triangle centroid to the whole centroid is G is there, no? That distance D is equal to how much? L divided by the root 3 will be there. Okay. Now I can write the moment of inertia about the any centroid value is equal to I plus 3 into I can write this is I dash. My I dash value I am writing. I dash is the moment of inertia of single triangle having mass m, side L, about G. Okay. This I plus 3 I dash value should be equal to 69. Why? Because big triangle I have divided into the 3 triangles about G, and one middle triangle is central triangle is G. Central triangle about G I have taken. Okay. So we can write it as 16I is equal to I plus 3I dash. 15I is equal to 3I dash. From this you can write I dash value is equal to 15I by 3. That is equal to 5I. This is my moment of inertia about I dash. Sorry, about G. Okay. I dash value I calculated. Now our step 3. Earlier I have told same manner we will follow the parallel axis theorem. Parallel axis theorem. According to parallel axis theorem, if I take any one triangle about G having mass m, length l, as per our relation, moment of inertia about G is equal to moment of inertia about, suppose this is C, about center point, plus m into distance between them. You know D is equal to L divided by the root 3. So I am writing just I am writing D square. Okay. M D square. We can write it as Iz is moment of inertia I dash. IC value is I, means moment of inertia about G and these all points. Okay. About the center point will be same only. Here I have taken now. Every centroid point is K into ML square. That is I. Plus M into, we can write it as L by root 3 whole square. I dash value already you have written 5I is equal to I plus M into L square divided by the 3. You can write the 4I, 5I minus I is 4I, that is equal to ml square by 3. So finally you will get I is equal to ml square divided by the 12. You observe this carefully. The moment of inertia of this triangular lamina is of 1 by 12 of ml square. Third option is the correct option. Observe this carefully how I calculated the moment of inertia. I am following 3 steps. Symmetrical body I am taking, bigger body. About any edge or corner or G I am calculating of the all the triangles, and parallel axis theorem I have applied. Okay. By using this I am going to do now JEE mains question, previous JEE mains question. As per the question, an equilateral triangle of triangle ABC is cut from a thin solid sheet of wood. See the figure. DEF are the midpoints of its sides as shown, and G is the centroid of the big triangle ABC, and similarly DEF also having same centroid G. The moment of inertia of triangle about an axis passing through G and perpendicular to the plane of the triangle is I0. If the smaller triangle DEF is removed from ABC, the moment of inertia of the remaining figure about the same axis is I. Then what is the value? Okay, you see here, as per the question, they have given that moment of inertia about the bigger triangle is they have given I naught. If I take the each triangle having mass m side L, mass m side L, this is also mass m side L, mass m side L. Okay, we can say 4m is the ABC triangle. ABC triangle is having, we can say ABC triangle is having mass 4m and side is 2L. Now I can write it as k times the 4m into 2L whole square, that is equal to 16 into k ml square is my I naught value. Okay, so 16 times the k ml square is my I naught value. In this case, we can see that middle one is removed. If middle one is removed, you can write it as, suppose say what is the value of I naught values, you know, that I naught value 16 k ml square. Now I naught by 16 is equal to k into ml square. That is the moment of inertia of the single triangle about centroid. Single triangle about centroid. About centroid. Centroid axis. Okay, I naught by 6. Now you see in this question they have removed middle one about G. Okay, this can be written as moment of inertia of the three triangles. Okay, as you know, moment of inertia of the remaining body is equal to you can see that moment of inertia of the ABC triangle means whole minus moment of inertia of the removed, which is one is removed triangle is DEF. Okay, so here moment of inertia whole triangle they have given I naught as per the question. You can say I naught is the moment of inertia whole triangle I naught minus removed one each triangle now having k into ml square, that is what here I naught by 16. So finally we'll get 15 I naught by 16, that's all. So you can write the 15 I naught divided by the 16 is the answer. Okay, now you can see this one. Okay, next question. ABC is a plane lamina of the shape of an equilateral triangle DE are midpoints of AB, AC. G is the centroid of the lamina. Moment of inertia of the lamina about an axis passing through G and perpendicular to the plane ABC is I naught. If ADE is removed, the moment of inertia of the remaining part about the same axis is n I naught divided by the 16, where n is an integer value of n value is how much. Okay, now observe this carefully. A big triangle is having the moment of inertia is how much. Let us consider that here also in the same manner we are doing four triangles I am taking. Four triangles I am taking. This is A, D, E and this is B, C. Big triangle having mass 4m and side is how much here? 2L I am taking. Moment of inertia as per the question they have given ABC is I naught, my I is equal to 16 times the K into ML square. Each triangle can be written as I naught divided by the 16 is equal to K into ML square. This k ml square is nothing but moment of inertia of each triangle about their centroid. About centroid like earlier. Okay. Now you observe this. If I remove the ADE part here, this part is removed. If I remove this part, how this moment of inertia changed? As we know that remaining moment of inertia about G is equal to moment of inertia of the ABC triangle minus moment of inertia of the removed triangle, that is ADE. ADE part is done that. I am calculating here moment of inertia about ABC is I naught. Moment of inertia of the ADE triangle is there, no, that I am writing here ADE triangle and G location is there. You know that the distance between them is L divided by the root 3. Earlier I have given L divided by the root 3. This can be calculated by using parallel axis theorem. What is the parallel axis theorem? Our side is L, mass is equal to m. We can write as moment of inertia about the centroid point. Centroid point is how much? I naught by 16. You see here I naught by 16 is equal to kml square plus m into distance square L divided by the root 3 whole square. This can be written as I naught minus I naught by 16 minus ml square divided by the 12. Again, as I have given in Pathfinder question, if any triangle is having mass m, length L, we can see that moment of inertia about the center point. Let us consider the C point. This C point is having moment of inertia I is equal to K into ml square. That K value you have got like a 1 by 12 into ml square. Okay, but we want ml square by 3. So you can write 4I is equal to ml square divided by the 3. So we can write it as ml square by 3 value is equal to 4I. Substitute this 4I value here. You can get the 15I naught divided by the 16 minus 4 times the I value is equal to, again I can write the 4 into I is equal to I naught divided by the 16. As we have seen earlier, K into ml square value is equal to I naught by 16. Okay, so that is I am taking like I. Okay, so I can write it as 4 I naught by 16. We can write it 15 I naught minus 4 I naught divided by the 16. We will get the 11 I naught divided by the 16. So that is our required answer. As per the question, n value is equal to much? 11. 11 is the answer. Our integer value is 11. Observe this carefully how I have written. Okay. Next one, square plate. If they ask you to calculate the moment of inertia of the square plate having mass is m, side A about its center point which is perpendicular to centroid, I have taken this G. Okay, same process. Let us consider the moment of inertia I is equal to K times the mass m side A, K into ma square. Step 1 I am following. Our step 1 is you consider the bigger square. This bigger square, I am going to divide this bigger square into 4 parts. This mass is 4m and side is 2a. This is a side total 2a. Here also a and a 2a. Mass is you can say that each mass is m. Here also mass m. Here also mass m. Here also mass m. Okay, you can see at this point this is a G point. Okay, I am writing moment of inertia. New mass is equal to 4m. New side is equal to 2a. So I can write this as K times the 4m into 2a whole square. So we can write it as 4 into 2 square is 4. Again 16k ma square is now my moment of inertia. So I can write the 16I is the moment of inertia of the square plate having mass 4m and side 2a about the centroid G. Okay, that is 16I. The same thing in the step 2 what I am following is we can treat this bigger square plate as mass m and side A having 4 square plates. See here, 4 square plates about G. So we can make into 4 square plates. These 4 square plates about G I am calculating. Okay, this can be written as 4 into I dash. What is the meaning of I dash? I dash is moment of inertia of square plate about corner G, any corner. Just I have taken here corner. Okay, so I am taking this square plate is how much here? Mass m and a. Okay, 4I dash value about corner I have written. This 4I dash value is equal to 16I. Why? Because at the center 4 parts I have written here, 4I at corner I have written 16I. We can write I dash is equal to 4I. I got the I dash value is equal to 4I. Okay, now step 3. Our step 3 is parallel axis theorem. Parallel axis theorem. Okay, now according to parallel axis theorem, if I take this square plate G is a corner, mass m and a, this let us consider C point. As the side is a, a corner to the C point is A by root 2. That is D. Moment of inertia about G is equal to moment of inertia about the center of mass of the square plate IC plus M into D square. What is the D square value here? I will write again, A by root 2. Okay. This value is moment of inertia about G is I dash. Moment of inertia about the C is I plus M into A by root 2 whole square. I dash value is 4I. I value is I only plus M A square divided by the 2. 4I minus I, that is 3I, is equal to M into A square divided by the 2. Finally, we will get I is equal to M A square divided by the 6. We can see our moment of inertia about the center of any square having mass M and side A is how much here? I is equal to M A square divided by the 6. Okay, I hope you will also apply to find out the moment of inertia of the any like symmetrical bodies are there, like a rod, like a square plate as well as a triangular plate. We can solve moment of inertia without doing any integration. Okay, extension question I am giving. I am going to give this solution for the upcoming video. Meanwhile, we can try this. Okay, as per the question, there is actually a stick. Actually, you can see, take a stick of length L and remove the middle third. Okay, if you take one stick, you remove the middle part. Middle part means we can divide this one into m by 3 mass. This is how much here? M by 3 mass, and last part is how much here? M by 3 mass. If we remove this middle part, we can see here there are the two masses. One is m by 3 mass, other one is m by 3. Middle is removed. Again, from the leftmost part, we have to remove the again 1/3 of the mass. Here only right side rod is the rod part, that is also remove the 1/3 of mass. Similarly, in this part, you have to remove 1/3. Here also middle 1/3. Here also 1/3, 1/3. Like this, it is continued. Okay. Then remove the middle third from each of the remaining 4 pieces. Also so on. You need to calculate moment of inertia about the, let us consider the point O. Okay, you can try that by using 3 steps. I told no earlier. First one is you take the symmetry. Second one is about end point. Third one is parallel axis theorem. Okay, by using that you can calculate the first question. Similarly, second question and third question also. We can see in the second question also, you can see there is a square plate side L, and removed middle square, like a 1/9 of the area is removed. Okay, this part is removed, and so on it is continued. Same manner you can see, and you can do it. Now you can see one more question, a triangular plate. In triangular plate also, middle part is here removed here. They have given 1/4 of the area is removed. Just now we have done previous JEE mains question now. Single middle part is removed, but here it is continued like this. Every time it is removing by 1/4 of the area. How to calculate moment of inertia of the remaining part, they are asking. You can try this. Okay, you can take this question. This question I will paste in I will post in YouTube also. You can take this one and you can try. Okay, I hope you have enjoyed this video. Thank you very much.